This is a video that's really more for your doctors or your providers or your complete science nerds. What I want to talk about is the difference in the different types of PCR testing because they're not all created equal. And the one that's been around for the longest, and I would say probably arguably the least expensive one, is actually the least accurate, right? Okay, so when you're doing a test or ordering a test online or whatever you're doing, bear this in mind. PCR, RT, reverse PCR, and qPCR tests can identify the organisms that are there, but they're highly suspect for false positives, meaning it says it's there, but it's not really there. And I think that the GI-MAP test and the ones in that family are definitely have a problem with this. They definitely do. The PCR testing that they use gives a lot of false positives, and my main concern about that is people being overtreated, right? If it says you have H. pylori or a parasite, then do a double check on it with another lab just to make sure that that can be confirmed before you embark on any kind of, especially prescription-based treatments. Okay, so here's what these tests do. A plain PCR test is a method used to amplify DNA from a small amount of DNA template. RT, or reverse transcriptase, PCR, uses reverse transcription to produce a DNA template from an RNA source that can then be amplified. The PCR and the reverse transcriptase, PCR, are typical endpoints in a reaction, while the qPCR and the RT-qPCR use the kinetics of the rate of product synthesis during the PCR reaction to quantify the amount of template present. So there's like an added check. Newer methods like digital PCR provide absolute quantitation of the initial DNA template, while methods such as isothermal PCR reduce the need for expensive equipment to provide results. But far and above the 16S RNA or WGS shotgun is really the only way to get a true look at microbiome health as a whole. And they can provide reliable measurements of relative abundance, plus you get some good looks at the functional potential of the microbiome. So with the 16S RNA or the WGS shotgun, those are the two you want. Those are the ones that are going to give you less problematic false positives. So they're not going to tell you something's there when it's not really there and it's not a problem. And what they use is universal PCR primers that can be designed to target the conserved region of the 16S, making it possible to amplify the gene in a wide range of different microorganisms from a single sample. Conveniently, the 16S RNA gene consists of both conserved and variable regions. While the conserved regions make universal application possible, sequencing the variable regions allows discrimination between specific different organisms, such as bacteria, archaea, and microbial eukarya. So that's important because now you've got two checks in one test to determine whether or not you've actually got the species there, and to determine its quantity, right? Because, with some of the older testing, there's an overlap between the fragments that they're using to identify, and those fragments are shared by other species. So that's the reason for those false positives. So I like a lab that will give me kind of a combination, like do the 16S or the shotgun, WSGS, or one of those more specific PCRs, in addition to, I want to see a culture. I want to see what actually grows. So what that means is that when you're sending your sample off, there should be two separate samples. One's live and one's dead. So if you're not doing that when you submit your sample, then it's probably not going to give you as accurate a result as you may want. And so if something comes up positive on one of the PCR tests, that is a PCR, reverse PCR, or qPCR, then just double check it to make sure it's really there once you get the results back with your doctor.